all of you ready for our class today? Okay, so before I start my class, okay, is it you have any question that you want to ask? While we wait for your friend. Okay, so now about 49 student. Okay, 49 student. Okay, solution. Okay, so before we start our class, we start with kita Al-Fatihah. So before we continue with for our content for this week, so we need to recap back what you have learned on the previous class. Okay, as I mentioned before in the first subtopic in the chapter 5. Okay, so you will learn about the again about the indirect and direct measurement. Okay, so from that you will know if you have an obstacle, so what is the action that you need to be taken. Okay, during the fieldwork to be carried out. Okay, and then if you have a hanging line, okay, so you have a radiation line, so you have a checking. Okay, so that one we call as a double independent check. Okay, and then for double independent check, you want to check the hanging line. Okay, and then from that they have a standard booking. Okay, that you need to follow. Actually, that booking you record okay, you measure the angle. Okay, so you measure the angle. If we look to the okay, so if you look to here. Okay, so the measurement have been taken. Okay, once you already finished set up the forward station. Okay, the forward station here for the line 3 to 4. So if you look here, okay, so you set up your equipment here. So 3 to 2 you refer, and then 3 to 4 is your forward station. So that is what you need to practice. Okay, once you go to site. When you go to site, in order you want to carry out the traversing, okay, so you need to set up the forward station first. Okay, and then later you try to locate is that any boundary mark here. Okay, so if you found the boundary mark, okay, so you will pick up by you refer 3 to 2 and then you observe 3 to 5. Then in order you want to check this hanging line, okay, so you observe 3 to 4 with any angle. Okay, so you can set with the 0 value. Then you observe 3 to 5. Then what you get the value. Okay, you get one value. That value actually the angle between 4, 3, 5. 4, 3, 5, the interior angle here. Okay, so once once you have a value 3 to 4, okay, this one 145 degree 45 minute and 20 second. Okay, you time with this interior angle, then should be you get a similar the value for the line from 3 to 5. Okay, the value here 215 degree 57 minute and 50 second. Okay, so that is how you check. Okay, and then how you need to book the data in the field book. Okay, so this is maybe you will look into your practical data. Okay, so you will look like this. Okay, 3 to 2, 3 to 4, 3 to 2, 3 to 5 seperti di atas, and then you have 3 to 4, 3 to 5. Okay, only on the face left. okay, set with 0 value, then you observe 3 to 5, then you get a 1 value. This value actually the angle. Okay, so this angle actually you time with the value for the line 3 to 4, should be you get the line, the value same as a line from 3 to 5. Okay, 215 degree, 557 minutes and 50 seconds. Okay, so that is how you check your data. Okay, so that's why here they have a checking. Okay, checking for the hanging line. Okay, so next, okay, we move to the how you want to record the data. How you want to record the data in your field book. Okay, so this one actually once you practice at the field, okay, so you will feel how to record the data. Okay, if you see like this, okay, so I think you feel this one is okay, so you can do it. But if you go to the site, okay, once you handle the equipment, you handle how you want to record the data. Okay, so you will think that for the first time, okay, it is difficult. It is difficult in order you want to record the data. Okay, so you can open page 106. Okay, 106 in your textbook. Okay, so anything you want to write down in your textbook, so you can okay, you can carry on because that is your textbook. Okay, and then your textbook you will okay bring on the other semester also as your guideline. Okay, so here the data measurement must be recorded using black ball pen, okay, and permanent. So that's why in the university level, okay, in the geometric, once you required to record the data in the field book, so I want the student to use the black pen. Okay, so the black pen, not the pencil. Okay, so if you have a mistake, okay, so you can okay, you can cancel, or you write down cancel, and then you can sign your okay based on your signature on the other side. Okay, so from that you will record as a on the new line, you will record as a new data. Okay, once you already cancel on the previous data. Okay, so here we focus on the in term of the bearing. Okay, okay, so you look must observe face left and face right. Okay, so that is a requirement. Okay, so you go to the site, you need to record the face left and face right. Okay, so where you want to get the reference line 2 to 1, so that you get from the datum line. Okay, so from the datum line you have in the mean bearing. Okay, so you will write down as a face left, then for the face right you plus minus with 180. Okay, so most of you I think already clear about this. Okay, but so this one you need to take note. Okay, okay, so this one another things. Okay, so okay, so same to the line for 2 to 3. Okay, but for this arrow I only show for the line 3 to 4, 4 to 5, and okay 5 to 6. Okay, so the difference between face left and face right should be not more than 20 seconds. Okay, so some of you may answer with the 10 second. Okay, but the allowable should be 20 second. Okay, so 20 second. So before you record the data, as I mentioned, okay, at the field, in the field, okay, before you record the data, so you need to check whether the data, okay, on the value on the face right, okay, is within 20 seconds or not. Okay, if not within 20 seconds, so try to observe again with the face right, face right. Okay, if you get the same value, so you try to observe on the face left again. So maybe you have a mistake from the face left. Okay, next, bearing must be recorded as nearest to 1 second. Okay, so as a requirement, okay, so you need to record all the data nearest to 1 second. Okay, so even though okay, your accuracy of the equipment, okay, so you have accuracy to 10 second, 5 second instrument, and then 1 second instrument. Okay, but in term of the value, okay, even though the 10-second equipment accuracy, so it also can provide the value nearest to 1 second. Even though the equipment 5-second accuracy, but the value can be shown as a 1 second. Okay, but if you want to use the accuracy of 1 second, okay, so that is too expensive. Okay, so in UITM, so basically what you will use, okay, on the semester 2, so you will use the equipment that the accuracy 5 second. Okay, the accuracy 5 second with the value can be provided nearest to the 1 second. Okay, so that one you need to clear. Okay. Okay, vertical angle must be recorded on both face. Okay, so this one same. Okay, for the once you carry out the daily check, you carry out the daily check, you want to continue your observation on the another day, so you required to record the vertical angle. Okay, so this vertical angle you record using the face left and face right. Okay. Okay. Other than that, okay. So other than that, you another things, okay, that you need to fill up in your field book. Okay. So example, you end of your traverse network, so should be you will have the C correction. Okay. So you need to apply the correction to all the line. Okay. And then in this sample, okay, you have the value of from the solar observation that you carry out, okay, 2 to 1. Okay, then you get the abducted bearing from the solar observation. So you write down 295 degree 20 minute and 46 second. Okay, so from that, compared to the mean value, so in the first line datum, so you will have the M correction. Okay, so that M correction you will apply to all the line. Okay, you will apply to all the line. Okay, I think someone want to enter to the class. Dah masuk ke? Ada yang dah masuk lah? Dah masuk belum?
Tak pasti je.
Tak pasti. Okay. So this is a problem. When you want to enter to the class, once I already start, okay, so I need to open the Google Meet interface. Okay, and then automatically you will enter. Okay, even though I already set as a okay auto admit. So we already until here. Okay, with the correction. Okay, then we move. Okay, so right. So I already okay. So I already brief about the bearing that you need to record. Then we move to the distance. Okay, so for the distance, okay, only horizontal distance must be recorded as a final distance. Okay, so this one you need to clear. Okay, same in the engineering. Okay, so in the engineering you need to record this one as a final horizontal distance. Okay, even though you take the vertical slope distance. Okay, slope distance for okay at this line at this line example in the engineering data, so this one should be slope distance. Then you require to calculate the horizontal distance based on the vertical angle and the slope distance, but in the cadastral only on the first line, okay, this line. And then example, you carry out a daily check, okay, in order you want to continue on the next day, so that also okay required you to record the data for final distance as a horizontal distance. Okay, so here, as you know, so this one slope distance, slope distance, because you already take the vertical angle. So once you record the vertical angles, automatic for this distance column, you will record as a slope distance. Okay, the final distance only the column okay reserved for the horizontal distance. Okay, so this one record the slope distance. Next. Okay, so all the distance you need to record on the both face. Okay, using the face left and face right, and then nearest to the three decimal places. Okay, 0.001 meter. Okay, distance difference on both face must not exceed 5 mm. Okay, example for this line 2 to 3. On the face left, you record 33.123. Okay, but on the face right, okay, once you observe, okay, you want to record the face right, so you get 33.129. Okay, 129. Okay, so is it still relevant or already more than the limit? Okay, more than the limit. Okay, because it's already the difference is already about 6 mm. Okay, so in order you want to check, okay, you want to check okay you as a surveyor or your friend observe, okay, so you need to make sure face left reading and face right should be not more than 5 mm. Okay, okay, so that about the distance. Okay, as I mentioned before in the booking, okay, for the first line only we take the vertical angle and the slope distance. Okay, so the other line you continue on the same day, okay, you will proceed with the no required for the vertical angle, and then for the distance you record as a horizontal distance, face left, face right. Okay, and then example tomorrow you continue, so the first thing that you need to do, you need to carry out the daily check. Okay, so in order you carry out the daily check, so you need to record the vertical angle and slope distance again. Okay, so this is okay the statement. Okay, so this statement I already briefed in your okay on the previous slide. And then okay, as you know, for the calibration differential field test, so you required to carry out for every new job. Okay, every new job differential field test or DFT every day. And then you continue okay, example you have one job and then you continue on the another day, so you required to carry out the daily check or daily test. Okay, in order you want to record the vertical angle, slope distance, and then horizontal distance, you check with the previous line for the horizontal distance. Okay, Okay, others requirement. Okay, others requirement in your field book. So you required to record the date of start and end job must be recorded and write in the temperature column. Okay, so if you look in your sample of the field book, so you will have the temperature column. Signature of the surveyor at all page at the bottom side of field book. Okay, so you as a surveyor, so you will have your signature on all page. Okay, at the bottom. Every page of the field book must write the page number of a diagram. Okay, so this one example you have a diagram. Okay, so you required to write down the page number. Okay, the diagram will consist about the north arrow. Okay, then district name, scale, traverse line in dash line with the black color, dot line in red color, and you will prepare as a continuous line or solid line. Okay, with the circle of a boundary marks. Bearing and distance must be shown in the traverse line. TR of sun observation must be shown in the diagram. Date signature of the surveyor. Okay, so the line that you carry out solar observation. Okay, so you need to show where the line that you carry out the solar observation. Next, for the correction, any correction must be cancelled and signature by the surveyor. Correction will be placed using a new rope. Okay, so you will not use a liquid. Okay, you use a liquid or you use a eraser example because of you use a pencil. Okay, so you are allowed to record the data with a black pen. A black pen only. Okay, so once you record, you already done you know about how to record the data in the field book. Okay, so example you go to the site. Okay, so you already record your data. Okay, then now you enter to the correction. Okay, a part of correction. Okay, all close traverse. Okay, example link and polygon must apply the C correction and M correction. Okay, what is C and M correction? C or close is applied on the close traverse network. Okay, its correction consists of systematic error, technical of instrumental handling by human and others. Those error will be reduced and eliminated using C correction. Okay, so you look to this okay, to this diagram. This diagram actually the same diagram as you learned in the chapter 4. Okay, but you will see the value that you need to apply for each line. Okay, example you start the observation with this value. Okay, but in the phase in your datum line, so you will write down as a datum 2 to 1. Okay, with the value what class? Is it you want to set this line with the 70 degree? Is it logic? You want to you go to the site and then you set with this value 2 to 1, 70 degree, 53 minute and 50 second to start your observation.
No, sir.
No, sir.
No.
Okay, so what you required to do?
Kena tambah 180.
Okay, so you need to time with 180. Okay, so means 2 to 1, you need to set with the 250, 250 degree. Okay, for the line 2 to 1. Okay, so that actually in the phase left. Okay, in the phase right, it will be as a 70 degree, 53 minutes and 50 second. Okay, so this is the value for the phase right actually. Okay, so then you continue your observation. Okay, next. Okay, so this one, this line represent as a closed bearing. Okay, so if you look your textbook, you look to your textbook, page 129. Okay, so you have the line closed bearing. Okay, so that actually, once you start with 2 to 1, then you need to close with 1 prime and 2 prime. Okay, 1 prime and 2 prime, that represent as your closed bearing. Okay, so where is 1 prime and 2 prime? So in your textbook, you can refer in your textbook. Okay, so this data, okay, represent as a 1 prime and 1 prime to 2 prime. Okay, the closed bearing value. Okay, so it's about I want to talk about the C correction. Okay, so you will apply, okay, to all the line with a different value. Okay, so then you will have the, okay, so we focus to the C correction first. Okay, from the closed bearing, okay, then you get okay, so now you have a 2 value. From the 2 value, you come up with the C correction statement. Then you will get the correction. Okay, you get the correction 30 minute 30 second. Okay, 30 second and negative 30 second. Then in your correction, so you will apply as a positive. So divide into 6 line. Okay, why 6 line? Because only 6 line that represent as your main traverse. Okay, your dash line here, your radiation line here and here not represent as your main traverse. Okay, so that's why you divide into 6. Okay, 6. Okay, so each line, okay, so you will have a, okay, with a different value. Okay, and that value will be accumulate. Okay, so dia akan berganda, dia akan meningkat. Okay, next for the radiation line, so you have two radiation line. Okay, here and here. So the observation 3 to 8, 3 to 8. Actually, you observe, okay, in based on the, you refer to the 3 to 2. Okay, so what you can do, you can take the correction 2 to 3. Okay, 2 to 3 that you get from the C correction. Okay, you take the value here, then you apply as a M correction for this radiation line. And then this line also same. Okay, you observe 5 to 7 based on you refer 5 to 4. Okay, in order you want to take the you want to apply the correction here. Okay, so you refer 5 to 4, so means you need to take the correction 4 to 5 from the C correction here, 15 second. So you apply to this radiation line as a M correction. Okay, so that is how you want to apply for the C correction in your main traverse, and then for your hanging line, you apply as a M correction. Okay, is it you clear? Class? Okay, okay.
Yes, sir.
Okay, so then, okay, so this is important, important. You need to write down, okay, before you have a C correction. Okay, example here, from this data, okay, line 1 to 2, okay, so you get from your mean bearing, okay, at this the close bearing, the last line 1 to 2, you get this value, then should be read. So you get from the face right, after datum, so you take from the face right. Okay, so you write down here, then you will get the difference in a negative. Okay, should be this one negative. Okay, negative. Okay, in 6 station. Okay, in 6 station, so means you divide by 6, so you get the correction positive 5 seconds for each station that you need to apply. Okay, so this is important. After your last line in your traversing, okay, so you need to write down this statement. Okay, so from here you will know how you calculate, how you get the C correction. Okay. Okay, so that about the C correction. Then we move to the M correction. Okay, so M correction referring to the meridian correction where the true orientation will apply in the traverse network. So example, you carry out the solar observation. So actually the solar observation will orientate your traverse network, okay, to the correct orientation. Okay, another example, okay, you will apply, okay, as when you use assume any bearing. Okay, you use assume any bearing to start your traverse. Okay, so you need to apply the uh, M correction. Using bearing from the CP value, where the orientation of the two line has different from the new one. Okay, using the solar observation. Okay, you take the value from the CP, okay, from the certified plan. Then when you compare with the value from the solar observation, so they have a different. Okay, so then you required to apply the M correction. Next, using bearing from the CP value with the linear mesh closure, second class and third class survey. Okay, so this one previous history of data in the certified plan. So they have a first class, second class, and third class. Okay, but nowadays second and third class, okay, will be handled by this survey department. Okay, in order to upgrade all this data to become as a first class survey. Next, wrong insert bearing in the total station. Okay, wrong insert the bearing. Okay, example, face left should be you record. Okay, you set with the 50 degree. Okay, you set with the 50 degree, but you record the face left with the 230. Okay, so that, okay, so you already have a mistake. Okay, you set the value, so from that you will have the M correction. Okay. Okay, so any solar observation, okay, you can carry out at any station. Okay, any station. Not only you start your observation 2 to 1, then you will start then you will carry out the solar observation from station number 2. Okay, so during you set up the station, okay, you go to the site, you set up the station. So you need to think maybe 1 or 2 station, okay, that you set up. That station, okay, capable to carry out the solar observation in the morning. Example, early in the morning, okay, or late in the evening. Okay, so that's you need to think. Okay, so as a surveyor, you need to be as a creative person. Okay, so you go to the site, then how you want to set up your station. Okay, not you can set up. Okay, you capable, you capable to set up at any station. Okay, at any place, at any location. Okay, for the station traverse. But other than that, you try to think. Okay, from this station, is it you can carry out the solar observation? Okay, and then from this station also you can offset to the nearest boundary mark. Okay, so that okay station that you create okay actually have a different function okay in your field observation. Okay, so I want to show the data. Okay, can you see this Microsoft Word?
Yes, sir.
Okay.
Yes, sir.
Okay, this actually okay. There's two sample of field book. Okay, two sample of the field book. Okay, so example here. Here, if you see, okay, if you see the solar observation have been carried out. Okay, uh, okay for this line. Okay, so that's why you will see the solar observation will be write down as a dengan matahari bearing akuit. Okay, so from here automatic you can calculate okay what is the m value. Okay, so m value, so here if you look here this one will be positive 10 second. Okay, so directly you calculate. Okay, but if you have a data like this, okay, the solar observation on the second line or the on the others line, so what you need to do? Okay, so what you need to do, is it the same as a sample number one, or they have a different? What do you think? Okay, so if you look here, the line datum, okay, the line datum here, so you will not have the, you will not apply the C correction, okay, either C plus or C minus, okay, so you will not have the C correction, okay, but here, okay, so but here you will have the, okay, you will have the C correction, okay, so from here you get, what do you get here? Okay, you get 90, 36 and 00. Okay, so then C correction, okay, C correction, okay, so you will look here, okay, and then you go to the bottom, ini hilang. Okay. Okay, example here, the C correction. Sekejap, saya kena buka satu. Okay, here will become 9, 45 and 35. Okay, so line 1 to 2 will be read as a this value, then you get should be read from here, okay, should be read, you get from here 944, 944 and 40. Okay, 944 and 40. So then from here you will get the difference. Okay, so the difference about 55 second. Okay, 55 seconds. Is it positive or negative? Positive or negative?
Positive.
Okay, positive. In how many stations? Okay, so we look one by one. Okay, 2, 3, 2, 3, then 4, 4, 2, 3, 4, 6, 6, and 1. Okay, so meaning we have 5 stations. Okay, so 5 station. Okay, 7 is not 7 is a hanging station. Okay, this one hanging line. This one double independent check. Okay, so this one also double independent check. Okay, so means you have 5 station, then your correction will be negative. C negative 11 second. Okay, C negative 11 second. Okay, so the C negative 11 second. So what you will do here, okay, so here you get 9:36:00. Then this one C negative 11 second. Okay, so from here you will compare these two value. Okay, this value with the from solar observation value. Then from that you will get the M correction. Okay, so you will get the M correction. Okay, so this one 90. Okay, 90:36:00. So minus 11 second. Okay, so you get one value. You need to minus with this value. Okay, so from that you will get the M correction. Okay, what is the M correction here? Can you calculate? If I calculate, I will understand. So if you calculate, you will understand. So the M value will be plus or minus? M value plus or minus?
Plus.
Minus. Okay, the others, what do you get? Is it minus? Minus or plus?
Plus.
Okay, plus
I got -2.
you got -2.
-2 sir.
Minus sir.
Minus sir.
Okay, so if you get you got minus, you got minus, what the value minus? Minus what? What the value? Student, what the value? Minus? Negative what? Okay, who mentioned about the positive value? Who said about positive value? Okay, quickly. I just want to know about the answer. Positive or negative? Are you still in the class?
Yes sir.
Okay, positive or negative? Positive or negative? Quickly, class. I have another things that I want to explain.
Sorry sir, I don't know sir.
Okay, you compare the value here. Okay, the value, this value. Okay. So this value with the C correction value with the value from the solar observation. So what do you get for the M correction here? Is it positive or negative?
Negative.
Negative. Okay. What the value? Negative what?
33 degree 33 minute 30 second.
33 degree.
Negative 33 minute 30 second.
Okay. Uh, so can you try plus? Okay, you have the mean value here. Okay, you have a mean value here. Then you have a C correction here. Then you have a M correction that you already calculate. Try you calculate all of this. Is it you get this value or not? Try to calculate. You get or not? Hmm?
I don't get sir.
You don't get. Okay. So another one, another person. Siapa tadi yang menjawab? Cuba you total up balik, dapat tak value yang dekat final bearing tu?
Tak dapat tu.
Tak dapat?
90 tolak 11 second ni.
Okay, so apa yang ada yang dapat positif tak value M correction? Is there any person get positive value for M correction? Okay, so what you need to do actually, okay, so what you need to do, okay, you take this value, okay, then you minus this value with the C correction. Okay, so I think you will get the positive value, M positive. Okay, try first. You will get the M positive.
What value sir? Again?
Huh?
Value
So
mana
what do you
tadi?
get?
Positif.
Dapat apa?
33 minit 19 second.
Okay, 33 minute and
30 seconds.
50 second.
19.
19 second.
Agak sikit balik.
Okay, the others, you get the same value, 33 minute and 19 second.
Yes, sir.
Okay, so now you try to total up again. Okay, you total up here this value. Is it you get the value in the final bearing? You get the value same as in the final bearing?
No, sir.
No. So try to calculate. The others, what do you get? So you calculate until you get the value of M correction.
Dapat, sir. 91 degree, 9 minutes and 30 seconds.
You get the value.
Yeah.
Okay. So the M correction will be M
30 minutes and
33 minutes.
33 minutes and 30 seconds.
30 second. 30 second.
Yes.
Okay. So the others, please check. You total up again. Then is it you get the final bearing?
Yes, sir.
Right. How do you get the value? So you need to, okay, I mentioned you need to okay, so this one, the mean bearing, okay, so you need to minus with the C correction first. Okay, so you get one value, that value, okay, you need to minus with this value. Okay, this value you minus with the mean bearing, okay, with the C correction that you already C minus or C plus. Okay, in this case, you already minus with the C correction. Then you will get one value here. Okay, so this value, when you total up with the mean, C correction, M correction, then you will get the final bearing. Okay. So this one still, I think, still have a mistake, not the correct answer, because you not solve with the C correction. Eh? So what do you get after you already minus with the C correction? M plus 33 minute and
41 seconds.
okay 41 seconds. Okay, so that is the value. Okay, that you get the M correction. Okay, if the solar observation have been carried out not in the first line, so in the others line like this. Okay, so this M correction, so you will apply to all the line in your traversing. Okay, to all the line in your traversing. Semua all the line you need to apply the M correction because you will orientate all the traverse network line. Okay.
Sir,
Okay.
the M correction is 35 minute 41 second.
Okay. Yeah. Why you get 35?
I get 30.
Huh?
30 or 35?
So
30,
the
right?
M 33 minute and
30.
uh,
I get
33
30 sir. 30 minute 41 second. Wrong
30 minute. 30 minute.
30 minute.
I think you're wrong. Try you total up again. When you total up, should be you get the final bearing. Thirty-three minute and 41 second. Okay. Okay. Is that any you want to ask about the booking? Anything you want to ask about related to the booking? Okay. So as I mentioned before, the C will be accumulate. Okay. Example. So here 223 as a first C correction. This one C2. Okay, C2. So you will have negative 22 seconds. Okay, the M correction still maintain. This one 322, 325. Okay, so you need to take the M correction here, apply here the C correction from 2 to 3. So you apply here as a M negative 11 second. Okay, another M you have from solar observation. Okay, for the cadastral, okay, it doesn't matter. Okay, you have a distance here, then you average, you put in the final distance. But the engineering you cannot do like this because in the engineering you have a vertical angle. This one slope distance, this one SD. Okay, you cannot average the SD and you put in the engineering. Okay, so this one what I see, that I see when I taught for the semester 2 student for engineering subject and cadastral subject. So basically in the engineering subject, a student will average this value and put in the final distance. So you cannot do that because in the engineering, this column will record as a slope distance. Okay. because you will have the height instrument, height target, and then in order you will transfer your heighting to another point. Okay, so that's why you have a vertical angle and slope distance. But in the cadastral only 2D data about the position, so that's why you're not required to have a vertical angle and slope distance for the each line. Okay, so anything you want to ask regarding this part of a booking? If not, I will proceed. Okay, so if no, okay, so I think you will not have a problem, okay, in your practical data. Okay, so you can just proceed, calculate, okay, apply the Bowditch method. Okay, so we continue. Okay, so once finished with the correction, okay, so you will proceed with the traverse adjustment. Okay, traverse adjustment. So in the traverse adjustment, in order to eliminate the remaining error, okay, in terms of a linear measurement in the traverse network after C and M correction, bearing and angle correction was applied. It can be checking using linear misclosure. Okay, so as I mentioned before, you start the observation at the point A. Okay, so when you start your at the point A, then you will close back to the same point, but actually you close at the A prime. Okay, so you cannot see, okay, human, okay, that start observation with A and then you will close at the same point with A. So meaning you not have in term of different X and different Y. Okay, so all human, okay, when carry out the observation, so they will have different X and different Y. Okay, so A to A prime, that represent as a linear misclosure. Okay, so what is the distance between A to A prime? Okay, so because of error in the traverse observation, angle and distance, if one were the begin at the point A of a closed polygon traverse, example from figure above, and progressively follow each course of it observed distance along its preliminary bearing or azimuth, one will finally return not to point A but to some others nearby point A prime. Okay, point A prime will be removed from A in an east-west direction by the departure misclosure and in a north-south direction by latitude misclosure. The distance between A and A prime is termed the linear misclosure of the traverse. Okay, so that linear misclosure you get actually from the delta X and delta Y. Okay, the different latitude and the different depart. Okay, so after you get the linear misclosure, okay, so you required to calculate the traverse accuracy. Okay, in the traverse accuracy, so from that you will see whether your traverse is achieved first class survey or not. Okay, actually you can look, okay, once you get the linear misclosure value, okay, so automatic you can know whether you will achieve first class survey or not. Okay, so if the linear misclosure value is bigger, okay, so bigger means you get a 0.05 meter above. Okay, so that is a too big different. Okay, so automatic, okay, your traverse, okay, your accuracy of the traverse is not the first class survey. Okay, so you can try later, okay, once you have a data. Okay, so once you already calculate, okay, so then you can proceed the adjustment using the Bowditch method. Okay, so you can use a Bowditch method nowadays. They will apply the least square adjustment method, so that related to the e-cadastral environment. Okay, so before 2009, so most of the surveyor will proceed with the Bowditch and transit method. Okay, so in our case, we will proceed focus on the Bowditch method. Okay, so known as a Bowditch or compass method. I think Bowditch method you already learned last semester, right?
Yes, sir.
Okay, so this one just for your revision. Okay, so for your revision. Okay, proportional to the line distance. Adjust the departure and latitude of the traverse course in proportion to their length. Although not as rigorous as the least square method, it does result in a logical distribution of mid-closure. Correction by this method are made according to the following rule. Okay, so this is a formula that you will use. Okay, total departure misclosure. Okay, divide by traverse perimeter, then you time with the length of AB. Okay, same goes to the latitude. Okay, so example here. Okay, example here you have okay, so this one you calculate the latitude and depart. Okay, in the calculator, what the function that you will use in order to calculate the latitude and depart? Shift polar or shift rectangular? The either one. It cannot be both. In order you want to calculate latitude and departure.
Right.
Shift.
Okay. Okay, in your textbook, okay, if you have a problem in terms of the calculation, okay, so you can open your page 96. Okay, 96. Okay, shift right, shift right. Okay, so you will use a distance, then you insert the bearing. Okay, then you will get the latitude and departure. Okay, so then at the end you will total up. Okay, so you get the error here. Okay, the total. Okay, the total departure, the total latitude misclosure here, and total departure misclosure here. Okay, so then you divide by the traverse perimeter. Okay, and then you time with the length of the line. Okay, example here for the latitude and departure for this line, you time with this distance. Okay. Okay, so you get here, then you need to minimize. You need to balance. Okay, you need to balance after you get the different delta latitude and delta depart. Then you need to make sure you balance the delta latitude and delta depart. So from that it will be zero after you have adjusted. After you have adjusted, so it will be zero. Okay, so from that you have one non-point. Example here, station 2, you have a non-point here. You have the coordinate. Okay, from this coordinate with the latitude and departure value adjusted, so then you can transfer from the non-point value coordinate to the others point coordinate. Okay, so from here you all the station you will have the coordinate. Okay, so once you already have the coordinate of each station, okay, from that you can calculate what you can calculate after you have a coordinate each of the point. You can calculate the area. Okay, so you can calculate the area based on the coordinate that you have. Okay. Okay, so that is in terms of the Bowditch method. Okay, so you will apply so you will apply to the main traverse. Okay, so to the main traverse example, in the diagram on the previous slide, you have a 6 station, 6 line. So only 6 line. Okay, you will involve in your calculation. Okay, so from here you can calculate the accuracy of the traverse. Okay, and then at the end you will have the coordinate of each the station. Then you will have the area of the land parcel, okay, that you carry out the measurement. Okay, so after you already calculate, so after you already calculate, okay, so you already identify, okay, so you already identify. Ya, ada yang baru masuk. Okay, so after you already done, okay, your calculation here, okay, so this calculation regarding your traverse, then you will have the lot and the lot data. Okay, so if we look here back, okay, so if we look here, okay, so you calculate for your okay, so you will calculate first your traversing, okay, so you will calculate the accuracy of your traversing. So at the end, actually, you need to calculate, you need to calculate your here, your lot, your lot line. Okay, your lot line here involved with this line, and then you involve with this line, and also with this line. Okay, so you have four line, that actually this one you need to prepare the certified plan. Okay, so you need to prepare the certified plan. Okay, not your traversing. Okay, so can you understand what I mean? Student?
Yes, sir.
Okay, can you understand or not?
Yes, sir. Yeah.
Yes. Suara nak tidur tu. You boleh faham ke tak ni? Dekat sini, dekat sini. Okay, when you carry out the measurement you have a traverse data kan. Okay, so bila traverse data you buat C collection, M collection semua lah. Okay, so dalam masa yang sama you ada radiation line tu. Okay, you ada radiation line dekat dua point di sini. Okay, point yang awal ni you dah guna sebagai part of your traverse. Okay, so you buat pengukuran untuk apa? Okay, you carry out the measurement in order you want to observe this land parcel. Okay, you want to observe this land parcel to become as a lot. Okay, so end of your result, okay, as in the certified plan, okay, so you need to show this land parcel, okay, this land parcel 7460, okay, as the final product. Not in the certified plan you show your traversing diagram. Okay, traversing is a guide to you in order you want to control, okay, to observe the land parcel of 7460. Okay, so at the end, okay, so you will have the final bearing 1 to 2, final bearing 2 to 8 here, final bearing 8 to 7 here, and final bearing 7 to 1 here. Okay, and then you will have a new area, a new area based on a new final bearing and final distance. Okay, so can you understand your final product in the certified plan? Okay. So same goes to your practical data. Practical data, if you look in your field booking, field book, okay, you try to sketch. Okay, you actually you want to observe to the lot 7455 if I'm not mistaken for group A. Group B saya tak ingat. Okay, Dr. Khairil already distribute. Betul? Data untuk practical. Group B? Tak ada student daripada group B ke?
Ada sir, ada.
Ada. So you ada dapat data untuk practical, betul? Data field book tu data field book lah. Ada. So
Ada,
dia
sir.
ada lot yang you kena measure tu. Okay, same goes to this example lah. Okay, macam group A dia dapat untuk measure 7455. Okay, so 7455. So first thing you akan ada data traversing. Data traversing tersebut dikontrol dalam masa yang sama, dia akan pick up kepada lot 7455. Okay, so you kena apply C correction, M correction, then you calculate the traverse accuracy, and then okay, so example here you pick up this boundary mark. Okay, you planted a new boundary mark here, then this one you pick up the existing boundary mark. Okay, from here, okay, so you will have a new bearing and distance here. Okay, 8 to 7, and then 8 to 2. Okay, so you have a new bearing and distance. This one also new bearing and distance. Okay, so if the line is already okay, use the existing bearing and distance, so you just maintain. Okay, but a new point that you observe, so actually you will have a new line that have a new bearing and distance. Okay, so at the end, once you have a new bearing and distance, so this one you will prepare your final output. Okay, certified plan in chapter 6. Okay, but before you produce the new output, so you need to have the calculation volume. Okay, so what is the calculation volume? Okay, so what is the calculation volume? Okay, so this calculation volume represent as a jilid kiraan. Okay, so jilid kiraan. So this one actually okay already applied before 2009, before the e-cadastral. Okay, so in this calculation volume, so it will show about the area, linear misclosure, and the final coordinate of the lot. Okay, so meaning regarding to the lot, example for group A, so you need to prepare the calculation volume for lot 7455. Okay, what is the area, what is the linear misclosure, what is the final coordinate of each point. Okay, so in the calculation volume, it will show the lot number, area, survey by, final bearing and final distance, standard sheet number, date of survey, and date approved. Okay, all CV data collect from the field book. Okay, so you collect from the field book. Example, you refer to the final bearing and final distance, and the coordinate by referring to the any certified plan that related. Okay, final bearing and final distance must be adjusted using any three of these adjustment. Okay, for you semester 2 you will apply the Bowditch method first. Okay, so until you already familiar, then next semester you will introduce with the D square method. Then calculation area. Okay, calculation area, final coordinate that already adjusted must be put in the calculation volume form. Okay, so you can look to here. So this is the example of a jilid kiraan from the survey department. Okay, example the lot 53606. So each of the station, okay, have the bearing and distance. Okay, and then on the right side they will have the coordinate of the point. Okay, so below of that they have a traverse accuracy. Okay, traverse accuracy, and then here you will have the area. Okay, area of the lot 53606. Okay, so this example from PKUP 2002. Okay, on the previous regulation. Okay, so this one another example. Okay. Okay, so below of that they will have the information. Okay, who will prepare this data, who approve this data, who as a surveyor that collect this data. Okay, where is the area, where is the location of the point. Okay, and the file number. Okay, so this one example from the JUPEM. Okay, from the JUPEM example, they have used the ETSM. Okay, the tough book. Okay, the tough book. They already apply using the tough book. They collect the data electronic. So the data will appear like this. Okay, in the electronic form. Okay, data yang diukur. Okay, and then existing NZCDB, the value of the point. Okay, from here we can see the different, okay, for each point. Okay, whether they have a different or not. Okay, so you can compare for from this data. Okay, so that for the chapter number 5. Okay, chapter number 5. Okay, other than that, in term of calculation. Okay, so the calculation, so we will discuss later. Okay, if you have the calculation sample that you want to ask, okay, so you can ask. Okay, from this chapter. Okay, chapter 5 you already finished. So my target, okay, you already know how to apply for the C correction and M correction. And then from that, you can use the Bowditch method to calculate, to balance the delta latitude and delta depart. Okay, the error that you get. Then you calculate the coordinate of each point. Later, you calculate the area of the lot. Okay, so that the aim from chapter 5. Okay, chapter 6, you will introduce with the certified plan. Okay, certified plan. What the requirement you need to show in the certified plan. Okay, why the certified plan is important. So that is in the certified chapter 5. Okay, so now any question you want to ask, okay, regarding your practical or okay, any things that related to the cadastral survey. Okay, the tutorial that you do, okay, tutorial that you do in this week. So actually you apply back what you have learned on the chapter 4. Okay, chapter 4, as I mentioned, you calculate the interior angle, then you look to the each line, the distance, is that more than 40 meter or less than 40 meter. Okay, so that from that, okay, so you will check whether that fulfill the statutory datum or not. Okay, So dia akan menunjukkan okey 3 batu tersebut dalam keadaan baik yang mana you boleh gunakan sebagai untuk you start you punya datum pengukuran. Okey, untuk datum pengukuran kamu. Dr. Berry. Okey. Ya, yang tu dekat mana maksud kamu tu? Soalan kat mana? Maksud kamu ni soalan tutorial? Okey. So dia kena at the end, okay, kalau at the end the conclusion, okay, the conclusion okay, adapter bearing so means the bearing that you will use, okay, in order you want to start your observation. Okay, so sebagai contoh, okay, sebagai contoh you punya example muka surat berapa? (61, 62). Okay, so 61, 62. Okay, so 61, 9 to 1. Okay, 9 to 1 and then 1 to 5. Okay. Alright, so they have a PO and new value. Okay, then adducted bearing. Okay, 146, 18. Okay. So that will be as a bearing yang you boleh guna pakai, okay, untuk you punya pengukuran, okay, untuk you start kerja kamu, okay, bearing akui bearing yang telah disahkan, okay, adapted bearing yang telah disahkan. Sama juga bila you carry out solar observation, okay, so that bearing yang you dah sahkan, okay, berdasarkan cerapan matahari, beza antara dua set tidak melebihi 10 second. Okey. Daripada situ you akan guna value tersebut dan you letak sebagai final bearing. Okey. Okey, next. Any question? Practical buat sampai mana? So practical, okey. Setiap minggu yang saya bagi guideline tu, okay, you minggu ni kena buat apa, minggu ni kena buat apa. Okay, so that is a guideline. If you already finish, okay, and then you want to move to another question, okay, so you can move. Don't wait until okay, week by week. Okay, so at the end you will prepare the report, okay, all the data that you provide on each week, okay, that you have. Okay, so you will compare, so that will become as your report. Okay, and then you will have a writing a little bit about the methodology, macam mana cara kerja, okay, what the equipment that involved, okay, what the aim and objective of this practical. Okay, so tu adalah report yang you perlu buat. Okay, so format report saya akan bagi dalam masa terdekat. Okay, if you not have any questions, so maybe you can ask personal. Okay, tak ada masalah, you boleh tanya personal. Okay, so now you need to open your web camera as your attendant.